Hello students, welcome back to our YouTube channel Sarvesh Study, and sorry for late. As you know that I'm making this video after a long time. So for late I want to say sorry to all the students. And today we are going to discuss about multiplication of vectors. As we know that there are two type of multiplication of vectors. First one is dot product, which is also known as scalar product. And second one is cross product, which is also known as vector product. Why we say that the dot product of two vectors is a scalar product also? Because when we find out the dot product of two vectors, then the result of these dot product is a scalar quantity, means it is represented by a vector dot b vector, and the result of these two vectors or dot product of these two vectors is a scalar quantity. Therefore we say that the dot product of two vector is also known as scalar product. Okay, and if we move on the cross product, it is also known as vector product, because when we find out the cross product of two vectors, the result is vector quantity, means there are two vectors, a vector and b vector, and we find out the cross product, which is represented by cross a vector cross b vector, that is equal to vector quantity. Okay, if we are going to discuss an example of dot cross product, that is the torque, which is a vector quantity and which is the cross product of momentum r vector cross force f vector. Okay, and the example of dot product is work done, which is scalar quantity, which is equal to dot product of force and displacement. Here force and displacement both are vector quantities, but when we find out the dot product of force and displacement, then the result is scalar and that quantity is work done. Okay, today we will discuss only in detail dot product. Okay, so now we are going to discuss dot product in detail. As we know that the dot product of two vectors is represented by a vector dot b vector, and its formula is mod of a vector mod of b vector cos of theta, where theta is the angle between two vectors a vector and b vector. If here this is one vector and this is another vector, this vector is a and this is b vector, then the angle between these two vectors is theta. Okay, so the dot product of two vector a vector and b vector is equal to mod of first vector and mod of second vector cos of theta. So this is the formula for dot product. Okay, now we are going to discuss the dot product of unit vector. Okay, so we know that there are three coordinate unit vectors. This is x-axis, this is y-axis, and this is z-axis. Okay, I cap is the unit vector along x axis, j cap is the unit vector along y axis, and k cap is the unit vector along z axis. Okay, if we want to find the dot product of two unit vectors, then we apply this formula on these. I cap dot j cap is equal to mod of first vector means I cap, mod of second vector means j cap, and cos of theta. Okay, but what is theta here? As we are seeing that the angle between x axis and y axis means I cap and j cap is 90 degree. So we take here theta is equal to 90 degree, and we know that cos 90 is 0. So total value are going to be 0, which means I cap dot j cap are going to be 0. Okay, similarly j cap dot k cap is 0, and k cap dot I cap is also equal to 0. Okay, means when we find out the dot product of two different unit vectors, just like I cap and j cap, or j cap and k cap, or k cap and I cap, then the dot product of these two unit vectors, different unit vectors, is going to be 0. Okay, now we will calculate the dot product of two same unit vectors. I cap dot I cap, it can be written as mod of first vector means I cap, mod of, and mod of second vector means mod of j cap, sorry, I cap again, and cos of theta. And what is the value of theta here? As we know that both vector are same, both unit vector are same, that is I cap and I cap, and we know that the angle between I cap and I cap is 0 degree. So we will take theta is equal to 0 degree, and we know that cos 0 is 1. So this value, and as we know that the mod of I cap is also 1. Why? We know that unit vector, what is the magnitude of unit vector? Magnitude of unit vector is also unity, or you can say that 1. So 1 and 1, and this is also 1, so it is going to be 1, which means dot product of two same unit vector is going to be 1. Similarly j cap dot j cap is also is equal to 1, and k cap dot k cap is also is equal to 1. Okay, this is the dot product of two unit vectors. Okay, now we are going to solve this numerical. A force 3I cap plus 4j cap Newton acts on a body and displaces it by 3I cap plus 4j cap meter. The work done by the force is, as we know that the dot product of force and displacement is going to be work done, means work done is equal to force dot displacement vector. Okay, so we will find out the work done here. Work done is equal to, what is force? 3I cap plus 4j cap dot, what is displacement here? 3I cap plus 4j cap. Okay, both are same item here. 3I cap dot 3I cap, 3 threes are 9 here, and I dot I is 1, so it is 1 into 9, so 9. Again 3I cap multiplied by 4j cap, 3 4s are 12, but I dot j cap is going to be 0, so this is going to be 0. 4j cap into 3I cap, which is also going to be 0. 4j cap into 4j cap, so 4 4 the what, 16. J cap dot j cap is 1, so it is 16 plus 9, that is 25 joule. And as we know that this quantity is a scalar quantity. Scalar quantity. So the answer is 25 joule, means option B is correct answer. Okay.